testing has been a very critical part. Okay, I think those who are in this line know. Okay, without testing, you can never be confident enough to say that your cable can support application. Okay, or your cable can support a new application 3 years down the road. You know that technology has been changing over the years, so cables is always installed in the building and can last 5 years. Sometimes government building can last 10 years. So you see a lot of new applications had to rely on the basic or the standard infrastructure, right? So we can talk about copper cable, talk about fiber cable, but at the end of the day, without testing, you will not know if we can support. So just to make sure that everyone can hear me correctly, so I believe everyone can see the slide also. If not, you just raise the hand or let me know. So whether is it called smart building, intelligent building, or digital building, I think this building, right, is compared with a lot of systems inside. Okay, so there are a lot of multiple platforms, the devices that run on, that the main objective is to make sure that the building, okay, is efficient. People talk about green building. The purpose of green building is to reduce the carbon output of a building, right? Reduce the power consumption, right? Reduce the use of air conditioning and so on. So a lot of devices has been put into the building to help to maintain and monitor, okay, the building function. So historically, I think in the building, right, I think the major part is the air conditioning, building security. Yeah. So this are one of the so-called traditional applications in the building that consume a lot of power, consume a lot of electricity. Now there are more things now. Okay, lighting, networking devices. Okay, to maximize and optimize the operations of a building. So next, we come to talk about Internet of Things, IoT. Oh, people hear IoT or this IoT. I think over the years, I found that people just reinvent the term. Okay, I mean, a lot of things is still the same. Okay, product is still the same. It's just that they reinvent the term to create, not to offend anyone, but to create a new kind of so-called expectations of a new product. Okay, but most of the time it's actually the same. So Internet of Things, I think it's basically talking about devices, okay, that are more intelligent now, all right, devices that can be connected to the internet, devices that can be monitored, tracked, and provide feedback as well. Okay, so Internet of Things is also talking about connecting all the devices in the building, okay, together. Okay, so that's why we call this IoT. Okay, so IoT means many different things across different markets. Okay, it's constantly making our devices more intelligent and more connected. Okay, so in the IoT devices, okay, it's talking about how these devices are able to perform connectivity with each other, okay, to ensure the whole building is being so-called operate, okay, to ensure that this technology is beneficial for the comfort, for the safety of the tenant inside the building, right? So at the end of the day, it has to serve some purpose, which is us, people that is inside the building, okay, to know that the building equipment provide us the so-called automation that we want, okay, the comfort that we want. So likewise, okay, like it or not, all these devices, all these IoT devices, okay, need cable, okay, need cable infrastructure to support them. So this today topic, again, we are talking about cables, okay. how can we manage this cabling infrastructure inside the building, okay, and how to ensure, okay, that it runs efficiently, okay, and even sometimes we need to troubleshoot as well, right? So if you know, I mean, those people in the cabling line, we are aware of the so-called Ethernet application, okay, that has so-called evolved, okay, through higher speed, through higher bandwidth, okay. So I remember when I started, it was just a transition between a Cat5 to a Cat5e, right? Now people are talking about Cat6a, or even people going to category 8 as well. So all this so-called technology, okay, are moving very fast, and the cable need to support that. Okay, the cable need to support that. So why the cable also evolve is because they know that all this Ethernet application needs a better performance cable, need sufficient bandwidth for the signal to pass through. Okay, so you can see that nowadays a new building are built based on Cat6a infrastructure, or at least minimum of Cat6 combined with fiber backbone as well. Okay, so time have changed. Okay, the intelligent building inside the device inside the intelligent building, okay, they are going to be centrally managed. Okay, why centrally managed? Because it's efficient. Okay, so they can manage all the so-called sensor, all the so-called temperature, or the condition of the building, okay, to ensure it is efficiently run. Okay, so every devices have different technologies. So how to link this up and what kind of equipment that you need to do when you test, right? But again, all these devices are so-called connected through the same cable now. In the past, we have different cable. We have 18 gauge cable, 16 gauge cable, we have coaxial cable, we have different kind of multiple cable to connect to the devices, right? Over the years, the devices has been designed and built to run on UTP, which is the same as we do connected to our IT equipment and technology. So on top of that, right, they are also running power on the same cable, which we know as a PoE, power over Ethernet. So as you can see, running on the same cable make it easier for building owner, make it easier for building contractors, because they don't need to worry about so many type of cables, just one type of cables, right? So the challenges, okay, we face when we do structured cabling, okay, in other words, the so-called issue that we face during when we connect IT cabling is the same for all these IoT cabling as well, since they are running on the same type of UTP cable. Okay, one of the biggest challenge is noise. Okay, we know noise, okay, will affect your signal. Okay, people talk about EMI noise, electrical interference noise, and so on. How this noise affect your signal is the same as if I'm talking now, okay, because my environment is considered quiet enough for you to hear my voice. But if there are external noise, maybe someone turn on the radio or someone is talking at the background, it will affect you from hearing my voice. Okay?
Okay.
Yes, so good example. Thank you very much. So it is very important, okay, to know that first, cable must be immune to noise, because then your signal will not be affected. Okay. And then the speed, okay, the speed of the signal, okay, will your cable support the speed required, okay, and then will it support the PoE? Now, PoE also evolved over time. Evolved in the sense that initially was very low wattage. People talking about 15 watts PoE. Now, the latest standard is talking about supporting up to 90 watts. why we want to support higher wattage. You see a lot of devices now have motors, have other form of electrical equipment inside that require higher wattage. Take for example a camera. In the past, people install a CCTV. This CCTV is fixed, okay? It's fixed means that it cannot move, right? So it requires very low wattage. But you know CCTV, there's other option of CCTV that can do panning, tilting, and zoom. So this requires additional motor in the CCTV, which require higher wattage. So in order to support CCTV, that's why PoE, okay, have various standards, okay, for different kind of wattage, which is the highest now is 90 watts. So all these things, okay, I talk about a general overview, describe what is about IoT, okay, and how important is IoT, and what kind of a demand, okay, the infrastructure need to perform in order to support the IoT. Next, we come to this test parameter, okay. So test parameters, when we do testing, a lot of probably user, when they look at the test result, they may not understand the implications of every parameter. What does it mean, okay, to your infrastructure? What does it mean to your signal? Okay, so let's talk about this, which is today one of the core subject that we want to talk about, the so-called the test parameter. When we think about physical cable plant, right? We talk about design consideration and the environment. Okay, cable have to be designed according to the environment. If you design so-called cable for industrial environment, so this environment is more harsh, so your cable must withstand the harsh environment. If you design a cabling system for data center, right? Again, the cable must be able to withstand the condition in a data center as well. Okay, so whether is it for the enterprise use or industrial use, okay, you will have different type of cable to install and test. Okay, and as you plan and prepare to test, okay, there is a lot of things to think about. Okay, so these are the questions that you need to think about. What is the deployment objective, right? Why you want to deploy this cable? What are the things that you need to support? Okay, what are the devices? You need to support CCTV, you need to support Wi-Fi access, you need to support your network, you need to support your security system. Okay, so what is the deployment objective? Okay, and what is the network environment? Okay, network environment talking about what kind of a system is connected. Okay, could be a 10 gig switch. Okay, could be a video signal, could be just an audio signal. What kind of network environment? Okay, and how would the thing be connected? Okay, it talk about how you manage at the end of the day, because everything will run back to the control center. Everything will be using a star topology linked back to a control center where they manage all the devices and all the connection. Okay, and if you're running PoE, how will the thing be powered? Okay, some devices is still traditional. In other words, if you need a power, you need to build a socket, power socket next to it. But now a lot of devices now are riding on the PoE platform. So they make the devices that can support the power through the RJ45 UTP port. Okay, and then the network speed. You know that internet, right? When we log into internet, maybe many years ago. Okay, when you have to use a modem to log into internet. Now we are using a cable modem. Now we are using a fiber network, okay, to connect up to modem. Now we are doing video streaming, all right. So you can see the requirement of speed, all right. It satisfies you to have things instantly. It satisfies you to see things work. If things start downloading and it takes 1 second delay or 2 second delay, okay, you may feel uncomfortable because we are become so-called tuned, okay, tuned to the speed of delivery now, okay. So what is the network speed? Always plan for the future, okay. Even though now maybe people are talking about 10 gig, even though 10 gig is still being adopted, right? Maybe it take down 3 years down the road. What will be the next? Maybe 40 gig on copper, okay. or 100 gig on fiber. Who knows, right? So you have to consider all this when you build the infrastructure. Why? Because you don't want to tear down next year to build in a new infrastructure. You always remember that cable is there, okay, to maximize it 5 years or 10 years, okay? So I hope everyone is still okay, following through, okay? Now we come to a bit of technical things, okay? So it may be too much to absorb, okay? I just want to simplify it, okay? And to show you all these things, okay? To let you know, okay? At the end of the day, when we test, what are the parameters? What does it mean, okay? So you can see these 4 different columns, okay? 4 different columns. The first column is more for cable certification. So if you install a CommScope cable, you install a 3M cable, you install a Penduit cable, right? The typical practice is that all the test results will be submitted back to the manufacturer, either to Penduit, CommScope, whichever brand you use. Okay. In return, if the result is satisfactory, they will give you a warranty. So this is what we call a cable certification parameter. The first part, when you test the length, the resistance, insertion loss, return loss, crosstalk, ACRF, TS, ACR. Okay, this will so-called show you that your cable, okay, when it pass, it meets the signal integrity of your network. Okay, could it be a 1 gig signal? Could it be 10 gig signal? Right? But when you start to employ IoT devices, there are a lot of other parameters that is critical. Okay, very critical. Why I say that is that it kind of tell you whether your cable can support. Okay, for example, PoE. When it comes to PoE testing, one of the basic parameters that we test is called the DCR. Okay, direct current resistance. So this DCR is important. Imagine if you have a pipe. Okay, if you have a big pipe. Okay, and in the middle of the pipe, something is squeezing the neck of the pipe. This is DCR. Okay, so DCR will restrict the flow of your power. So you have to measure, because it's based on measuring the copper quality. How good is your copper quality? Okay, so if your copper quality is no good, your DCR will be high. In translation, your PoE may not be. Your PoE loss, your power loss will be higher. Okay, so this parameter is not part of the cable certification. Okay, it could when you submit to Penduit or CommScope, whether it pass or fail to CommScope or Penduit or 3M, they are not really concerned about this parameter. Okay, so in the tester, there is an option. Okay, option to so-called have this parameter tested, but will not show pass and fail. Okay, so this option is used. So if there's a fail in DCR, it's a fail in TCL or ELTCL, it does not affect the cable certification. But what we want to go through now is that we want to encourage, okay, to make sure that even this measurement, this additional parameter, DCR, TCL, okay, is also put to a pass and fail requirement. Okay, so you can see the first column and the second column. I don't know whether you can see my mouse. First column say TIA Cat6A channel. The other column TIA Cat6A++. So these 2 different settings allow to test the TCL with a pass or fail. Okay, so ++ is an option for the user to decide. Okay, so if they want to measure this additional parameter and to make sure that this parameter also pass, they have to select the ++. Okay, so it may be a bit confusing for those who may not be familiar with the parameter, but don't worry. What I'm trying to emphasize in this testing is that, okay, when we test cable, we want to make sure we test the full range. Not only support the network, but also support the IoT devices. Okay, so if you look further on the last column, okay, so there is additional testing in the tester which can support the network signal and PoE. Okay, why is this important? Now we say that now the power is running on the same cable in the same jacket beside your data signal. Okay, so what will you think of the issue that will cause? Noise. Okay, imagine power and signal running side by side inside the same cable, inside the same jacket, right? So this measurement allow you to measure the signal noise ratio in terms of what we call, if I don't block you, is, let me cover myself, it's called the signal noise ratio, SNR. So this SNR measures the ratio between the signal and noise. Okay, if your noise is higher, you get a negative value. Okay, but if your signal is higher, you get very good margin. Like for example, in the presentation in the slide here, 10 gig I get 3.2 dB, which is a very decent and very good margin. Okay, so a couple of points I want to make about this test, called this options parameter, is why are so important is that, you know, DCR against within the pair is important because it enable you to know whether you can support your PoE. It's a kind of like qualification for PoE. Okay, so if your DCR fail, your PoE may fail. Right? So this is what we call testing. Okay, looking at the different parameter, it will give you different performance qualification for different devices. Okay, so I hope everyone is still good. Okay, so again, a bit of reviewing what I just said earlier on this so-called slide. Okay, as you can see, the DCR, right? DCR. Now, this DCR is not just measuring the DC resistance of the whole cable. First, we also measure the unbalanced in pair, and then unbalanced pair to pair. Okay, so it helps you to qualify your cable. Okay, based on the DCR, if it's good enough to perform PoE, right? So many of you may have some questions or in mind when I present this slide. Just again, as I say, just put your question on the chat. So Leo, at the end of the day, we will still go back to the question, all right, to try to answer and give you a good response, right? So at the end of the day, as a user, actually you do not need to worry everything. All you need to do is do the setting, okay, and make sure that all the parameters in the cable pass, okay? And by setting the optional testing, it will give you better assurance. Okay, so what happens if you get failure? Okay, this is the thing that we want to avoid. Okay, so optional parameter will tell you more things. It's just like when you go for health checkup. Sometimes when you go for health checkup, okay, there are different kind of package, right? A simple package, you know, test for blood test, test for cholesterol, cancer marker, you know, test for glucose, for your diabetes and so on. Then there's another package, what called plus, where they go even in depth. Maybe you go for MRI, ECG test. So it's something like this, okay? A plus means that we will go in depth, okay, to measure the cable, to give you a full performance of pass and fail, okay, of your cable, okay? So it helps you to give you a good so-called view on how healthy is your cable, whether it can support your IoT, okay? So this is what I'm trying to say, okay? This is what I'm trying to say. So pass and fail help to give you attention. Hey, your cable, there's some problem with your DCR. Hey, your cable got some problem with the DCR resistance. It may not be supported. It's telling you it may not support PoE. Okay. So don't worry. I mean, if you get this, okay, we can troubleshoot. We can do rectifications. Okay, maybe the failure comes from the patch cord. Maybe the failure comes from the connector, which can be resolved. Okay. So important. Okay, for those who are involved in building application, those are involved in ELV system running on the same UTP cable, you have to take note on this, right? So as you install IoT connected devices, okay, let's say customer has already a cable there, okay. It could be so because a lot of buildings are very old, and a lot of time they want to relay a new cable. Okay, first is because they may not have enough space above the ceiling or in the riser or even in the cable tray. There's not enough space, right? So you need to run devices on existing cable. Okay, if that is the so-called job that you got, okay, it is very important that you retest the cable. Okay, whether it's a Cat 5e or Cat 6 existing, you have to retest the cable. So when you retest, it gives you also assurance that whether your new IoT devices can be implemented. You also tell a customer, if it's not, then no choice. Okay, take the painful process of redeploying a new cable. Okay, rather than you make a mistake and then go and install the device and found it didn't work. You know, it didn't work. So this is also one of the things that why it is important to test. Okay. So earlier part I talked about SNR. Okay. So I mean, a lot of people never take in consideration the noise. Okay, in the environment. Okay, the noise is actually more on the electrical noise or the EMI interference, right? Many IoT devices fail because of this noise. Sometimes it's hard, okay, hard to troubleshoot, okay, hard to get a good diagnostic on what causes the failure to your sensor, what causes failure to your camera. How come got this intermittent problem? Okay, so it is always noise is very hard to so-called locate. So when we test this parameter called the SNR, okay, so it helps to ensure that in this environment where your signal run, okay, the actual environment where the signal run, okay, it gives you a very comfort level that, okay, your signal, the SNR is good. That means your signal to the noise barrier performance and the margin is good, that your signal will not be affected. Okay, so when we do this testing, actually there is a lot of so-called application involved. Okay, when we do this testing, we can do this when during the live mode. Live mode means, okay, it is connected to a live switch. There is signal passing through the cable, and we measure on the spot. Okay, so we measure the traffic to measure a real world scenario. So it gives you a good environment. Okay, so if you have intermittent problem, this parameter will help you to indicate where is the issue, right? So if you run higher data rate, let's say you're going straight to 10 gig, it is more sensitive for 10 gig. Okay, it is more sensitive. So if there's a slight noise, okay, this signal will be affected. So you can see in this slide here, right? I have 3 parameters. All is based on copper: 2.5, 5, and 10. 2.5, I got 11 dB. Okay, because this is a slightly lower data rate, so the margin is higher. But when you go higher to 10 gig, your margin becomes 3.2. Okay, so data center now is running on 10 gig. Okay, so this important measurement helps to allow you to indicate whether your signal is good. And on top of the SNR, okay, again we measure the PoE at the same time. So we are doing dual measurement if you look at the slide. Okay, the other screen displayed there on the right hand side, okay, it have a PoE. So besides measuring SNR, if your switch or your switch is providing power to your devices, besides data, and then you also provide power, it helps to measure the output. Output, okay, that means the power travel along the cable. What is your real power? Okay, so you can see that this measurement is very, very useful. First, it tells you your cable has no issue about the data signal. Second, it tells you that your power running over the cable, there will be losses. Okay, let me emphasize that there will be losses. If you plug in a 90-watt power source, there will be losses along the cable. This is acceptable based on the IEEE standard. But the losses, okay, but the losses should not be a lot. That means at the end of the output, okay, at the end of the cable, your measure output should be a certain range. Okay, so for this example, for 90 watts power, okay, your cable is about 18 meters based on the display. Okay, that means your losses, there will be losses, but your power output is 78 watts. Okay, so devices, again, there's a spec. If you look at every devices, there's a minimum wattage for the devices to run. Okay, so if 78 watt is above your requirement, that means the devices has no issue. Right. So a lot of things to consider. Okay, so but as a user, okay, by testing all this, again, it gives you very good confidence. It gives you good assurance. Then come to new things. Okay, we always thought that every devices will run on 4 pair, but not so. What I realized, a lot of devices sometimes do not need 4 pair. Some they only need 1 pair, which in this term called single pair Ethernet SPE. Okay, so building automations has been using traditional cable, usually the 2-wire copper. Okay, now they are so-called transiting over to a UTP cable, which is a 1-pair cable. Okay, so what are the devices? What are the applications? It's like lighting. Okay, it is like sensor. Okay, can be motion, temperature sensor running on single pair. Okay, so even with the same tester that we built, we cater for this type of testing limit. Okay, so it helps you to really have a very diversified testing on the same tester to test on different kind of 1-pair cable to a 4-pair cable. Okay, and this single pair again is not just birth out of devices requirement. It's again based on the standard. Okay, based on the standard that this deployment is required by mostly building automation system. Who are the automation supplier? One of the famous company is Honeywell, right? Followed by Johnson Control. So these 2 companies are doing a lot of building automation. Okay, so SPE single pair internet follow the same testing methodology. Okay, so you get the same test result. You get the return loss, you get the insertion loss, you get the length measurement, but they based on a different limit. Okay, they are not basing on the Cat6 limit. They are not basing on Cat5e limit, but a different, which is provided by the IEEE. Okay, IEEE standard. Right. So it may be a lot to understand, but I'm trying to simplify and try to give you a very good understanding of what is all this testing all about. Of course, we talk about copper. Copper is one of the cable media. What about fiber? Fiber follow the standard TIA measurement. Okay, we call tier 1 measurement. So fiber against, okay, is being used, okay, because of the bandwidth they can provide, because of the distance they can cover, right? So we are talking about fiber as the normal fiber that we have seen. It can be a 2-core fiber up to 24 or 48-core fiber. But the fiber itself is not sufficient to support IoT devices. That's why the next part that come in, the type of product that come in, we call hybrid. Okay, you heard of hybrid car. Car can run on petrol, car can run on battery at the same time. So hybrid power fiber, which is a fiber cable plus 2 copper wire in the cable itself. This is designed to support IoT devices. Okay, so when it comes to this, okay, the tester is designed is also to measure 2 types of cable at one go. That means I can measure the fiber plus copper at the same time. Okay, so these measurements allow you to measure the fiber, allow you to measure the copper as well. Okay, what kind of measurement for this copper? We measure the DCR because the copper is going to be used purely to support power and voltage. We measure the output voltage, okay, inside the copper with a hybrid fiber. Okay, so the tester is designed to allow customer, okay, use this hybrid fiber to test both fiber and copper. Okay, here I don't have the slide, but just to give you an idea where actual application is being used now for this hybrid fiber. Okay, you heard of telco running 5G network. Okay, in order for them to implement 5G, that means when you buy a 5G mobile phone, in order to connect to 5G, okay, they need to have devices inside the building. It's like an AP or Wi-Fi device that's installed, spread around the building layout, okay, to provide you the 5G signal. Now, these devices are running on two types of cable media. One is a basic Cat6A shielded cable that support the signal for the 5G device and power. The next is a hybrid fiber. Okay, we see a lot of 5G devices, telco devices that running on fiber uses hybrid fiber. So the copper is to support the power to power up the 5G. Okay, another application which is not very common is in the harsh environment industry. One of the industry is mining. Okay, in mining, you know, there's a lot of tunnel going very deep. So, but they also install, one of the applications they install is a camera, CCTV. And this camera running very deep inside the tunnel. And they don't use copper because copper is not long enough. So they use fiber, they use hybrid fiber to support the camera. So this is a two known application that I know use a lot of hybrid fiber for their device. Okay, so besides ensuring the cable certification, besides ensuring the PoE can support the PoE, besides can support the SNR, signal noise ratio, okay? And then at the end of the day, it's a real thing now is that now your network is up, okay? Your switches is up, whether you put in Cisco switch, Dell switch, whatever equipment that you put in, okay? Now it's an operation mode, okay? So you want to test your network capability now, okay? You want to ensure your network is connected, okay? So in the same tester, we put in a lot of network testing application. It is very useful. IT administrator, especially IT administrator, when they go around checking failure, okay, to support the company operation, IT operation, okay, they can use this function, okay, to check and troubleshoot their network. Okay, what are the functions, okay, that it gives you? First, it gives you cable function. That means if your cable is connected, your cable infrastructure is okay. It checks your network component. That means your devices, it can do discovery. Okay, how many devices is connected? How many network components are installed? How many IoT is connected to these devices? Right? You also do Wi-Fi checking, Wi-Fi strength. If you look at the slide also, there is a Wi-Fi display, strength display, okay, based on your SSID. Okay, so at all these things, okay, so these are talking about actually layer 3 under the OSI layer 3 testing. Okay, it check your physical cable, it check your network component level, right? It gives you a full detail of the network switch, right? It gives you the MAC address, okay, it can do ping, it can do discovery. So it is testing is all fall under the same tester, right? Now, I hope all this testing provide you a glimpse, okay, of what all this parameter means and how important it is, right? And it is what we call about the requirement, okay? Then we talk about alternative power technology, okay? So PoE is we can't escape PoE. We love talking about PoE because this is one of the biggest technology shifts. Okay, a lot of devices are moving to that. In fact, in future, okay, your laptop will be powered by PoE as well. Okay, you do not need a power socket. As long as you plug in the RJ45, it will power up your laptop. So it's a shift, okay, with modern intelligent building. It means that majority of IoT devices will receive their power through the UTP cable. Okay, why people like it? Building owner like it because it is a very high, it is an impact on their overall cost saving, especially their capital cost. Okay, and it helps the building environment improve the building environment footprint. In other words, you do not need to have multiple cable tray. One type of tray to support this type of cable. Okay, and the contractor uses, okay, only one type of cable, whether it's single pair or 4-pair, right? So as you can see, okay, this is a very good direction, okay, to look at it, okay, to look at testing for new environments, especially for PoE, whether it's a PoE, PoE plus, PoE plus, okay. Of course, there are people talking about the higher than 90 watts, okay, and also looking at hybrid power. Okay, so a little bit of IEEE spec, okay, when we look at this so-called wattage, okay. So the last column are what we are talking about, the real power. That means at the end of the cable, you measure the power output. This is the minimum that you should get based on the IEEE standard. For 90 watts, you should get a minimum of 71.3 wattage. Okay, anything less than that is considered non-compliant. Anything less than that is considered failure. Okay, so type 1 is known as a 2-pair. Okay, it's based on IEEE 802.3 AF. While type 2 is known as PoE plus, right, which can go up to 30 watts. All right. Now type 3, which is still a lot of people trying to adopt type 3, okay, which is running on 4-pair cable. Okay, how it works with the signal running on the same pair, okay, is based on the devices, the way their devices send the signal and power. Okay, so this is talking about 60 watts and above. Okay, 60 watts and above. Okay, so PoE plus is a lot of people trying to adopt it because it can power up many devices. All right. So look at all these standards. Okay, driven by the standard. When this standard is driven, all the components must be ready to support all these requirements and standards. Okay. So here is a quick example, you know, where we did a few years back, or so-called a real-world deployment, okay, with 1,000 feet or 1,000 kilometers of cables, okay, over different kind of devices, okay. So they have different kind of power level, okay, they are connected to, okay. So imagine this will be the future configurations for future building, okay. So people are moving into this direction, connecting all the devices on the same cable, okay, and the testing had to be readjusted to support all these requirements. Besides support cable certification, you have to make sure that the signal is not affected by the noise. You have to make sure that the PoE can run. A lot, right? It's a lot now looking at just cable. It's no longer just, oh, pass return loss, pass crosstalk, oh, pass connectivities, okay, there's no breakage, it's good enough. It's no longer enough. So you have to consider all these factors, okay? So as you know, the devices are built by a lot of so-called equipment manufacturer, okay? So it is not uncommon, okay? Things will still go wrong, okay? Things will still go wrong. The PoE will drop over a long distance of cable, okay? Or some cable have some DCR problems and so on. There's always the issue, okay? That people will say, oh, it's because your device is not working. Oh, because your cable is not working. Okay, how many people face that? I'm sure you face that. Okay, I'm sure you face that. Okay, many times, right? Of course, I can ask you to raise your hand, but anyway, I can't see it. Okay, but I hope that you can relate to what I say. Things can still go wrong. Okay, so it is good idea to perform testing. Okay, and one of the testing, actually, another new testing I want to introduce to you is what we call a load testing. Load testing means that we are putting up an actual device, putting up an actual load, okay, to monitor it for a period of time. Okay, so how do you know? Sometimes it's like a life cycle test. It's just like a life cycle test. Okay, every devices or every so-called devices that you buy, like a handphone, you go through a life cycle test. Okay, which is called the load test. So cable also can go through load test. On my next slide. Okay, so this is how we perform a load test. Okay, what is connected is not really shown here. Okay, it's basically that we plug into a live device or plug into a so-called devices, and we monitor it for a period of time. Could be 2 hours, could be 4 hours. Okay, and you see this reading on the screen here, especially the load test, the last display here. You will keep on fluctuating up, down, up, down, up, down. Okay, so it will tell you how stable is your power. All right, so this test is not really performed very commonly. That means it's not really common to perform this test because you will need additional devices to perform the load test. You need a period of time, okay, for this test to run. Okay, usually like minimum 2 hours to run, right? So when you push the lightning symbol there, okay, that means the requested load is then put onto the wire. That means now there is power, and the test equipment receive the power through the power device and report based on the voltage, based on the current, and based on the real power. And this reading will keep on changing, okay, because this is continuously testing, right? Okay, so I'm coming to an end soon. So overview of testing of power over single pair Ethernet. Again, this is the same principle. It's just that it's only running on single pair Ethernet, right? However, the application is more for automation, okay, and also run on automotive, okay. So, but in the building, I will still encourage more on the 4-pair devices, right? Single pair is good, okay, because a lot of devices do not need 4-pair. They just want a single pair. So a lot of building automation control like lighting, security, access, sensor are running on single pair. Okay, so let me go to the next slide. So this is a typical example of a hybrid power. On the same jacket, you have 2 core fiber and also 2 copper wire. So this wire is thicker than the UTP. Could be 18 gauge, okay, up to 12 gauge, right? And this was just purely supporting power, right? So you get a glimpse of the picture that how we do our testing on our tester. So the both fiber and copper is plugged into the tester. And what is the result you get? First, you get fiber measurement. You measure the loss, you measure the distance of the fiber, and you measure the DCR of your copper. Again, DCR value is tied back to your PoE, your power. Okay, so it is time saving because you test 2 at the same time. Okay. So at the end of the day, after all this testing, again, of course, it's report. Okay, it is important because at the end of the day, you need to have this evidence to keep as a record. Okay, whether if you are a contractor or installer, you need this to provide to the end user, say everything has been tested, that the cable can support your IT network, the cable can support your IoT devices, the cable meets a PoE requirement, the cable has a good SNR ratio, okay, for a cable. So with this report, okay, it provides confidence and assurance to the end user, okay. So we have a full report for especially for smart building, okay, whether it's copper cable or fiber cable, right? And also individual report like the signal noise ratio report, the POE report. And if your customer still want to use coaxial for some application, we also can have a coaxial report as well. Okay. So in this
多謝爸爸你。
唔制，爸爸唔知，即係影響點幫我考慮啊？
Okay, so this is what I call SNR. So in summary, okay, why we go through this is to emphasize on testing. Okay, we are facing a new world, new design, new building setup. All right, there are so many devices out there. Okay, lighting manufacturer is making their device, camera manufacturer is making their IoT device, building automation, they're building their new IoT device, right? And they are trying to run it on the same UTP cable. Okay, because this one helps to be in the building, you only have one type of cable. So it lowers the cost of the capital cost. Okay, so in order to deploy all these devices, everything needs to be tested. Okay, everything needs to be tested. As a contractor that lay the cable to support all these devices, it helps you to understand what are the testing requirements and what are you testing for, right? So the last slide just showing you the product that we have, okay, in the market. Okay, so the tester itself is very built. Okay, we actually don't call ourselves a cable tester. It's more a multi-function cable tester because it's not just testing cable. It's testing your POE, it's testing your SNR. Okay, so you see two types of model there. One is basically meant for the cable installer, where you require two units, okay, the master and the remote unit, okay, in order to perform a complete cable test, okay, and this is also required by the certification, whether ComScope certification, Pendule certification, or 3M certification. While the other unit, which is a bit Tiffany blue color, right, as you can see the tester below, okay, is also good for, this is good for end user. Right, they do not need two units, they only need one unit. It's to troubleshoot, to validate, okay, to see what goes wrong with the cable, to add on new features, okay, if let's say your cable going to run new devices, whether you can support the current, the new application, okay. So everything is changeable through the adapter. By changing the adapter, allow you to do tests for different applications. So smart building, intelligent building represent a significant change in the landscape of your enterprise network. Okay, while it brings increasing complexity in testing, okay, with the right tool sets, okay, like what we have built, okay, it is good for the current and modern building. Okay, and it allows you to have a new service, okay, opportunity as a contractor or as an installer to provide to your customer. Okay, because this allow you to have one different kind of test with one tool. Okay, and for users who manage, okay, the in-house or in-building application day to day, right? A tool that can help you, okay, to troubleshoot, to test, to ensure that your cable can support new devices or new equipment. Okay, it helps you to bridge the gap, okay, between the cable certifications, okay, and qualification. Okay, so we have two kinds of testers to provide, right, for all different kind of users. Okay, it takes about 1 hour of my presentation, and I appreciate those who stay and listen, right? It is at the end of the thing to take away is testing. Okay, testing is to go beyond the cable testing. So now we will go through the questions, and if you have any questions, just feel free to add on. Okay, and probably Leo will help me to read out the questions.
Yeah, there's a few questions already lah, so they are probably message me. So okay. Okay, for the POE development types, so I think I will better to share the question inside the chat room now, because so easy to everyone to go through the question there.
Sure.
Okay, so the first one is the actual power available at PD. What is the distance from the source to PD?
Yes. So one of the things that the cable is running, the cable infrastructure, the topology is running on is based on the TIA standard. So the TIA standards, as you know, when you run structured cable, you cannot go more than 90 meters for permanent link or 100 meters for channel link. So it's still based on the same distance limit set by the TIA. So for fiber, of course, it's very different. Fiber, you can run longer distance, but again, depend on the Ethernet signal that you're running on. Yeah. I hope that helps.
Okay, so I will go through to the second question now. Okay, so here the question there. Do we need a constant load to test the PoE load test section?
Yes. Okay. So when we try, okay, one of the things that PoE devices has is what we call, I don't know if we use the right term, handshake. Okay. When the PoE source, okay, recognize the devices, you open up the channel for power to pump through. First is for safety reason. Second thing is more for so-called to ensure that you don't generate power unnecessarily if there's no devices connected. Okay, so for us to ensure that the power continuous running through the cable, we provide a so-called a load test equipment to simulate their devices, to open up the channel for the PSC or power source equipment, okay, to let them know that, oh, there is a devices connected, we need to continue to supply the power, right? So this is what I'm trying to say. Okay, so when we do the load test, it's not a common test to do. Okay, you need a separate load to simulate a devices, whether 15 watt devices, 90 watt devices, and so on. So I hope that helped to give you a understanding of what you mean by load test.
Okay, so this question is from Noru. So Noru, boleh tepat lah to answer. Okay, so we come to the third question. This is from JKR1. Okay, for the testing purpose, okay, what is the specific competent person or the certification do we need?
So when we come to testing, it's more than just pushing the button. Because I see a lot of people who do testing, right? They only are trained to connect to end, set to the right limit, and press a button. Even some people don't even set the limit; they just go there and press a button, right? So I guess is that if people who are doing this project and doing testing, right? It is good to equip, okay, with the basic understanding of different parameters that being tested. What do you mean by crosstalk? What do you mean by return loss, right? So I found that this information, right, is now when you Google search or Yahoo search, it's everywhere. There's a lot of video, there's a lot of document that you can understand the parameter. Okay. Then the second thing, the going in depth is to troubleshoot. Now troubleshoot, of course, it will take some form of experience to understand or diagnose what will be the likely cause of failure. Okay, there is no one standard cause of failure. Okay, so there could be a different factor. It could be the component quality, it could be the installation issue, it could be the equipment issue, right? So I guess when we want to learn about testing, I mean, like ZW, okay, Koa is very experienced guy. He know from the test result whether your cable is healthy. It's just like doctor. You go to a general pediatrician, GP doctor, or you go to a specialist that can tell you even more information. So I guess it can be learned. Okay, it can be learned, it can be trained, okay, to provide better understanding when you do the testing. Right. So if this is a very key subject, I mean, Koa can arrange next time we can just do a subject on testing 101. Right. So I hope that helps. You can I mean, Koa can send you a lot of information as well.
Okay, So this the question so far I collected. So for others, do you all got any external question? No need direct. you all no need to private me the message. You
Yeah,
can
you
just
can
open
type in the
inside the
chat
chat box.
group.
No need to
I can
private
try
me.
to read the chat group at the same time. Yeah.
Yeah.
So
Okay, so there's a question for Eugene. Okay. Are device on PoE connection safe from power surge and lightning impact?
okay, when we do IT cabling, structured cabling, right? One of the things that the standard that emphasized is talking about grounding. Okay, grounding for the cabling. So grounding for the cabling is because our cable is connected to sometimes live equipment. Okay, so our cable, we need to do grounding at the equipment rack. Okay, grounding at the patch panel. Okay, and if you are using shielded cable, you need to do additional ground. So what is the purpose of the grounding? Is to prevent any surge. Okay, to prevent any surge. Of course, there are a lot of compliance when you run your electrical equipment. Okay, there's a circuit breaker that you need to put in. Okay, to ensure there's no power surge that will damage the equipment. All right. So, of course, this will be talking about electrical protection, grounding, bonding, to safeguard your cable, to safeguard the security or safety of the people that handle the equipment. Yeah. Okay. So I hope that gives you a good view. Yeah. Thank you very much. Thank you, Eugene.
Okay. So is there others question? So today we got around 70 participants.
Yeah, because I do not know your role, your job. I mean, at the end of the day, whether you directly handle testing or indirectly handle testing, or whether you are end user or whether you are installer. I mean, at the end of the day, you just have to important that what the infrastructure that you have, right, is actually helping you to run your building more efficiently, making sure that all the devices connected is working. Okay, and down the road, 3 years down the road, if you decide to change the equipment, you also consider whether your equipment can support, whether your cable can support your new equipment.
There's one more question add on here. Okay, related to the search, is this the SPD device are recommended or mandatory?
What is SPD device? Sorry, again. Regarding the search protecting device, is it? Okay, I mean, I try to provide it. If the answer is not aligned, let me know. So
yes, sir.
Okay, so there are a lot of market additional devices to prevent surge, but as we know, the IoT devices are running on what we call a low voltage, a low power, right? Which is similar to the ELV system, right? So there is, of course, against good practice, okay, to do grounding and bonding. Okay, this is actually emphasized on the TIA standard 569 specification. So when we do cabling, okay, we always emphasize that grounding and bonding is critical. So touch wood, especially in our Asia climate, we got a lot of tropical storm, we got a lot of lightning storm. If the building ground is not well protected and the current surge to the equipment, first, it damages your equipment, definitely. But the worst, if that is a so-called causes safety to the persons using it, right? So this is things that we need to take note. Okay, so I think that is a very good question. I think on this lightning search or search electrical search. Yeah.
Okay, so any else from others?
The shielded UTP cables, how to ground it?
Okay, if you look at every manufacturer, right, there is a installation guide. Okay, when you shield it inside the cable, okay, there are two things inside the cable. One, it could be a foil, okay, foil, and then there is a continuous wire, a bare wire. We call drain wire. then that drain wire is the one that you need to do grounding, because that drain wire is connected to your foil. So your drain wire had to be connected to the connector itself, right? That is a metal, if I'm not mistaken, many of them will have a metal bracket where you need to connect the drain wire to the metal bracket. Okay, so when you are connected, okay, especially at the end of the patch panel, where your patch panel could be a shaded patch panel, the shaded patch panel will come with a small copper connection. Okay, it's either one of the end of the patch panel, and that is to tie back to your grounding. Okay, it will be there. If not, by looking at the installation guide, okay, it will show you. Okay, so when we ground structure cabling, we only ground mostly at the patch panel end. Okay, so I hope this help you to visualize how is it being ground. If we found cable was broken, 2 core, out 8 core, no signal, how do we know where is? So I believe that you are referring to fiber. So usually fiber, okay, the tester is what we call a tier 1 testing, right? In tier 1 testing, it only gives you 2 major measurements. One is the length of the cable and what we call the fiber loss value, okay? So if you want to have a locator, okay, a locator to see where is the broken location of the fiber, then we use a tier 2 fiber measurement. They call it OTDR, okay, optical time domain reflector, okay. Now this tester, which is slightly bigger, okay, it gives you a so-called graphic of the whole link, okay, and the link, in the middle of the link, there will be some spikes, okay, so it will tell you where is the part that is broken. Now, of course, OTDR comes with additional cost, right? At this moment, our tester is a tier 1 tester equipment, which is good enough for fiber testing. And also, I mean, if let's say there's fiber broken, okay, it is not really advised to join it back, okay? You increase the so-called the losses. Usually, if fiber broken, either replace, okay, replace, or you use the other 6 core that is working. Yeah. Okay, so Alan, thank you. So SFA, SDP is mandatory for low voltage, yes. I think whether you have electrical system, I think this is still mandatory. It's part of a building requirement. Okay, building, that's why building always specify you have to have a building ground. Okay, now in a traditional building 10, 20 years ago, there's only 1 tile ground. Okay, when go back to the basement or NDF room, you have 1 tile ground. Now new building have 2 tile ground. They want to separate the ground. One is for the electrical ground, where all the electrical cables are running back to the ground. And then a new ground called communication ground. Okay, if I'm not mistaken, now new building will have this communication ground where tie back all your IT cabling back to this ground. If Cat 6A, okay, then you're talking about pair, right? Okay, for copper cable, okay, our tester can locate the point of failure. Okay, can locate exactly where it's distant. Okay, for copper cable, if there is any broken, damage, okay, it will tell you where's the location. Okay.
Yeah, one more question here.
Yeah.
For the hybrid fiber.
Okay, I welcome all these questions, and I try to give you a good response for every question.
Okay, so the hybrid fiber optic cable.
Okay, so again, the devices will have their own grounding. Okay, so for copper cables at the end of the connectivities, okay, the so-called the copper cable, okay, have their own ground, usually ground back to the panel. Okay,
The question is, since the hybrid fiber optic got a copper cable as well, so the attenders will like to know the SPD requirement for this.
Correct. So the hybrid cable will go back to the fiber patch panel. Okay. When they split at the end, I'm saying when they split at the end, the fiber will go back to the fiber patch panel, while the other two wire copper, okay, will go back to the devices. Maybe direct, let's say direct. That means go back to the power device. Okay. If we go direct, the power devices have their own ground. Okay, that means we are tapping on the device's ground, the power source ground. Okay, so if there's any surge, it will not damage the end devices at the other end. Okay.
So anyone one more question only. I think the time is quite over already.
No worry, I think at the end of this session, I think we want to learn from each other at the end of the day.
Yeah.
I mean, I based on my experience at the site, I see a lot of failure. I see a lot of issue, especially customers who are running critical operation. Critical means that let's say you're running a bank, okay, you don't want to afford to have breakdown with this cable mistake, or you're running a data center, you don't want to have failure, or you're running a stock exchange, or you're running a hospital environment, okay. You don't want your critical infrastructure to fail, and then your operation cannot run, and then not only cause productivity loss, but also cause revenue loss. Okay, so it is very important why when we install cable, testing help us to give additional assurance.
Okay, so is there any extra question? Okay, so don't worry everyone. Dixon has had been come to present the what we call the training for a few times already. So incoming in future, I also believe that he will be keep on to update all the information with us lah. So don't worry, you can keep incoming if you got any question like facing about for the testing part. So I believe that Dixon will be like to give a more what we call the feedback and also the sharing to you all. Okay, so
maybe before you end. So I think with the MCO going on, I mean once the thing is being settled and left, if I think the best thing is that you contact ZetaBase, arrange for a demo, okay, that they can show you how the testing works. I think talking like that is also very challenging because it's very hard for you to see how the equipment works, okay, how the cable is being tested. So if once the so-called permit, once the things open up, feel free to contact ZetaBase. I mean, Guo has a set, he can demo to you. Worst come to worst, he do a live demo online. Yeah.
Yeah, he done before.
Yeah, I think that will be better. I mean, to see it is better than just what I'm talking to. Yeah.
Okay, so for the coming next session, I would like to pass to Mr. Kwa. So Mr. Kwa, are you here?
Okay, let me stop sharing.
Yeah. Kwa, your mic is not operating. I cannot hear anything.
Hello, can you hear me?
Yeah, I can hear.
Now okay,
Yeah, okay.
Okay, thank you. I would like to express my thousand or million thanks to Mr. Dixon. It was conducted such a very meaningful and very very informative, and I think a lot of people may not able to digest all the information. But I hope this thing we will do more on this one. I can see the next topic is very interesting. Actually, is grounding and earthing. Okay, grounding and earthing, I think is maybe people will consider is a good topic also. I don't. If those people you all think, you want to learn more on the grounding earthing, I will get another expert to give a training talking about how to do the good grounding. If everybody you are okay with this arrangement, please put 1111. Then I will know how many people will like to join this training. Then I will get the I will get the expert come to teach more on the grounding area. I think grounding is important now. Okay. Okay. I can good response. Thank you. Thank you. Thank you for response. Then I mean this will push more to do more to get the expert. I'm just now talking to him. He will let me know whether he able to do the training for this grounding thing. Okay. Before that is my next topic. We're going to do it for you.